Okay, let's move on now to the law of cosines. Okay, I don't like the law of cosines as much as I like the law of sines, and you may have a different opinion, and that's fine. I do love the law of cosines. It's very useful, very helpful, but it looks a little larger, a little bulkier to me. It has more stuff in it than the law of sines has. So this one's a little harder for me to remember, but I'm going to give you a couple techniques that might help you to remember it, okay? So before we talk about the law of cosines, I want to quickly review the law of sines so that we can see how the law of cosines is a little bit different. We used the law of sines to be able to find either an angle measure or a side length when we already had three pieces of information. In every case, we either had two angles and one side, or we had one angle and two sides that were known to us. Okay. Now, one of the key important aspects of the law of sines is that you always had to have at least one pair of an angle and a side. So if we knew side A, we had to know angle A. Or if we knew side C, we had to know angle C. Or if we knew side B, we had to know angle B. There had to be a pair of the angle that was opposite of the side, which makes sense because the law of sines, sine is opposite over hypotenuse, right? So we needed the opposite in play, okay? So the other possibility was, we said we either need to know, so if we knew B and C, the sides B and C, we either needed to know angle B or angle C. If we knew angles A and B, then we either needed to know side B or side A, okay, in order to use the law of sines. Okay, so now the law of cosines comes in. You might have thought to yourself when looking at the law of sines, you might have thought, yeah, but what if I don't have one of the opposite pairs? What if I know side A and side B, but I don't know angle A or angle B? What if I only know angle C? Now I don't have a pair. I don't have what I need for the law of sines. Well, that's where the law of cosines comes in. The law of cosines, now you have an angle with two adjacent sides. Remember, cosine is associated with the adjacent side. So the law of cosines now can help out in that situation where the law of sines fails, okay, or just can't be applied. I don't want to say it fails, it just can't be applied. The other possibility is you might have thought to yourself, well, what if I know all three sides and I just don't know any of the angle measures? What am I going to do then? Well, obviously the law of sines can't be applied because you need at least one angle for the law of sines. Well, here's the cool thing. The law of cosines, if you know all three sides, the law of cosines will allow you to find at least one of the angles. Actually, it'll allow you to find all three of the angles, but in reality, you only need to find two of them, because then you can just use the idea that, you know, the sum of the three angles is 180 degrees. Now, let's just say for the moment that you did have the thought, well, what if I know two of the angles and the side that's in between them? So I know side A and I know angle C and I know angle B. How am I going to find the rest of the stuff? Well, remember, if you know angle C and angle B, you now can find angle A because all three angles add up to 180 degrees, right? So you add these two angles together, subtract from 180, that gives you angle A. Now you have enough information to use the law of sines, okay? So the law of cosines is primarily when, in fact, I have it right over here, you can find an angle measure when you already know all three sides. So if you know the lengths of all three sides, you can use the law of cosines to find an angle measure, okay? Or you want to find the third side length when you know two of the sides, but you don't have either of the opposite angles. You actually have the angle measure that's between the two sides. So as long as you have those pieces of information, you can use the law of cosines and you can find out the rest of the information that you need. Okay? All right, so law of cosines, let's look at the formula here then. Now this can be written in a lot of ways. But here's what I want you to focus on as we look at this formula, is that what we are trying to solve for is always the letter C, okay? So here, when it says we want to find an angle measure, okay, if we're trying to find an angle measure, we're going to call that angle measure. We're always going to call the angle that we're trying to find angle C, okay? Now, you could just as easily rewrite the law of cosines here. It doesn't have to be as C and then A and then B. You could make this angle B, but if you make this angle B, then you have to make this letter B, you have to make this letter C, and you have to make this letter C also. But that's so, I don't know if you think that's confusing. That's confusing to me. Okay, I'd rather only have just the one formula, and then I understand that whatever I'm looking for, if I'm looking for an angle, I'm solving for angle C. If I'm trying to find a side length, I'm trying to find the length of side C. Okay, so typically this is the unknown side that you're trying to solve for, or this is the unknown angle that you're trying to solve for. Okay, so if you look at this formula, so we got C squared, the length of side C squared is equal to the length of side A squared plus the length of B squared minus 2 times side A times side B times the cosine of angle C. Yes, hopefully by now you can see, I can see why Mr. Ryan doesn't like this one as much as he likes the law of sines. Now I do want to show you something I do really like about this, about the law of cosines is, look what happens if we cover this up over here. What do you see there? A squared plus B squared equals C squared, okay, right? That's correct. If you recall, that's the Pythagorean theorem. So you can actually see the Pythagorean theorem as that is a part of the law of cosines. And it would apply. And let me show you how it would apply. If, let's say that we had a right triangle, okay, and let's say that that the right angle is angle C, okay? And so then the opposite side is side C, and then we can call this side A and side B. So we know that in a right triangle, A squared plus B squared equals C squared, right? A squared plus B squared equals C squared. And you say, yeah, but what about the minus 2AB times cosine of C? Well, what is cosine of a 90-degree angle? Well, cosine of a 90-degree angle, or it's the same thing as cosine of pi over 2. Think about that, right? Do you recall from the unit circle that cosine of a 90-degree angle is 0? And therefore, we could put on minus 2AB times cosine of C, because cosine of C is 0. 2AB times 0 is 0. Minus 0 means it's not even there. And then we just get C squared is equal to A squared plus B squared. Okay? That's just a little aside. I just wanted to show you that the Pythagorean theorem is inside of there, and it is consistent with the Pythagorean theorem. Okay? But really all we're going to do in this lesson, don't worry about any of that. All we want to do in this lesson is I want to do maybe 4 examples of applying the law of cosines to situations where we either know all 3 sides and we want to find an angle, or we know all 3 sides and we want to find all 3 angles. And then the other situation is where we know 2 sides and 1 angle and we want to find the other side. Okay, so let's go ahead and jump into a couple examples right now. All right, so here we have a triangle where one of the sides has a length of 12, one of the sides has a length of 10, and one of the sides has a length of 17. And we have an x, a variable here, x, in one of the angles. And it says find x in degrees and radians. So what we're going to do is basically what that just means is that when we get to the end of the answer, we can find it, we can make sure we use our calculator, because you're going to need a calculator for this. And we'll do the problem once in degrees, and then we'll do the problem once in radians, okay? And then we'll be able to find the answer for x in both degrees and radians, okay? All right, so we've got 3 sides, no angle measures, so we can't use the law of sines, so we're going to use the law of cosines, okay? So we're going to take this formula here, and we got to pick. Now, honestly, here's the thing. This is very important. You have to understand. Because we're solving for x here, okay, and that represents angle C. This always represents the angle. Whatever is inside the cosine is your angle. And what's important is that whatever side is opposite of that has to be side C. Now, it doesn't matter which of these two is A and B. That doesn't matter at all. What does matter is that the side that is opposite of the angle has to be side C, okay? So we're going to call this one C, and then let's call this one A, and we'll call this one B. Okay? All right, so we're going to set this up. It says C squared, so that's going to be 10. C is 10. 10 squared is equal to A squared. Well, A is 12, so go 12 squared plus B squared. B is 17, so I'll put 17 squared minus 2 A times B. Again, A is 12, B is 17. Okay. Now it doesn't matter. I told you before. It doesn't matter which one's A and B. Okay. And there are a lot of mathematical reasons why it doesn't matter in the formula. And then we're going to say times cosine of x. Okay, because x is what we're solving for in this case. Okay. All right. So let's go ahead and work out some arithmetic here. Grab a calculator. We know that 10 squared is 100 equals 12 squared is 144 plus, maybe we don't know what 17 squared is. 17 squared is 289 minus 2 times 12 times 17. 2 times 12 times 17. We got 408 times cosine of x. Now let's not mess with this cosine of x for a little while. Let's work out all of this other arithmetic and algebra, and then this will be one of the last things we do. So 144 plus 289 is 433. So we got 100 equals 433 minus 408 cosine of x. Okay. Now we just need to do some algebra. We're trying to solve for x, so we need to move everything on the right side here over to the left side. Now we can switch it around if we want to, but let's not worry about that right now. This 433, we can do something about that. We're going to subtract 433 from both sides, minus 433. Okay. Over here it's going to cancel, bring down the equal sign. 100 minus 433 is negative 333. Okay. Carry down the negative 408 cosine of x. Okay. Now we want to get the cosine of x by itself, so we're going to divide by negative 408. That's going to cancel this negative 408. Over here we'll also divide by negative 408. Okay, so we're going to cancel here. Now what we have is cosine of x is equal to 333 over 408. Now this negative over negative, those are going to cancel because a negative divided by a negative is a positive. So now we just have 333 over 408. So I'm gonna rewrite it here. Cosine of x is equal to, because all we have left over here is cosine of x, is equal to 333 divided by 408. Now, you could turn this into a decimal if you wanted to, which would be 0.816176471. But I'm going to leave it as a fraction because I don't want to round anything right now. I'm going to say this again. I say it as many times as I can. Do not ever round your answer until you get to the very final answer. The one that you're going to write in put in the box or write on the line, the final answer, that's when you round. Okay? All right, so here, how are we going to handle this cosine of x? Well, we did this in the law of sines. When we had sine of a and we needed to cancel the sign, we had to do the inverse of sine. Well, now we're going to do the inverse of cosine. So what we're going to do to both sides is we're going to do cosine inverse, right? Arc cosine. Cosine inverse to both sides. Cosine inverse. And now what we have is cosine inverse is going to cancel cosine, and we now have x is equal to cosine inverse of 333 over 408, right? And now we can just key this into the calculator. Whoops, excuse me. Sorry about that. So I'm going to go cosine inverse. I got to hit second, then the cosine button. Oh, also, so here's the thing. I need this answer in degrees and radians. So I'm going to do cosine inverse of 333 over 408. I'm going to do it with my calculator in degree mode, and then I'm going to do it again with my calculator in radian mode, and that's how I'm going to get my two answers. So right now I'm in degree mode. So I'm going to hit cosine inverse of 333 divided by 408, and that's going to give me x is equal to 35.3 degrees. It's actually 35.296, but the 6 rounds the 9 up to 10, and the 1 on the 10 goes with the 2 and becomes a 3. Okay, so it's 35.3 degrees, okay, rounded. And then my second answer, x is equal to, I'm going to switch over, I'm going to hit the DRG button and go over to rad for radians. Then I'm going to do cosine inverse of 333 divided by 408, and I get x is equal to 0.62 radians. That's rounded, okay? But it's a final answer, so it's actually 0.616033939, but 0.616, if I'm rounding to here, this tells me to make this one go up by 1, and that makes it 0.62, okay? So 0.62 radians. All right, so we just found the measure of this angle, okay? Well, let's say now that we wanted to know the measure of the other two angles. All right, well, let's try that in our next example. Okay, so what I've done is we're sticking with the same example, and I've gone ahead and put 35.3 degrees in on this angle right here, okay? And now we have a new question, so we have y, the variable y over here, and let's say it says find y in degrees and radians, okay? Well, here's something cool. Now that we have a side length and a degrees that are across from each other, we could use the law of sines to do this. But this video is on the law of cosines, so we're going to use the law of cosines. Okay, well, in order to find this angle, okay, that we need to be dealing in the side that is across from it, okay? And so over here, we're going to call this side over here, this one is now going to be C, right? So now there's a couple ways that we could do this. Well, I'm sorry, to find an angle measure with the law of cosines, there's only one way to do it. We need to use the three sides, okay? And so we're going to let's call this one B again, and then we'll call this one A, okay? And so now we're just going to do the exact same thing we did in the last example. We're going to take our formula, we're going to put this in, 12 in everywhere we see side C, we're going to put 17 in for B, and we're going to put 10 in for A. So it says C squared, so that's 12 squared, is equal to A squared, A in this case is 10, so 10 squared plus B squared, B is 17, all right, 17 squared, minus 2 times A is 10, B is 17 times cosine of, in this case, it's angle Y, okay? All right, so 12 squared, that is 144, is equal to 10 squared, that's 100, plus 17 squared, 289, minus 2 times 10 times 17. So 17 times 10 is 170. 170 times 2 is 340. All right, times cosine of y, okay? All right, so now we have 144 is equal to 100 plus 289 is 389 minus 340 cosine of y. Now we're going to subtract 389 from both sides, minus 389. We're going to carry down negative 340 cosine of y. All right, and 144 minus 389, let's see, 289, 285, 245. So negative 245. Okay. Now we're going to divide both sides by negative 340. So we're going to cancel on this side, divide by negative 340. Okay. And now we on one side we have cosine of y, so I'm going to switch it around, move this to the left side, doesn't matter. Cosine of y is equal to, the negatives are going to cancel, negative divided by negative is a positive, so we just have 245 over 340. Now, 245 ends with a 5, 340 ends with a 0. That means that this can be reduced, and depending on how it's reduced, it could actually wind up being a decimal. So I'm going to do, let's see how it works out. On 245 divided by 5 gives us 49. 340 divided by 5 gives us 68. So we got 49 over 68. Now you could just leave it as 245 over 340. That's fine. You're just, actually, you know what, just to make it easier for you in case I don't want to confuse you guys too much. 245 over 340. But just know that you can reduce the fraction if you want to, but you don't have to reduce the fraction because this isn't being put in as a final answer, okay? All right, so we got cosine of y is equal to 245 over 340. So now to cancel the cosine, we got to do cosine inverse to both sides. Cosine inverse, inverse. That's on the left side, it's going to cancel the cosine, carry down the y, and so now y is equal to cosine inverse of 245 over 340. Okay. All right, and now we can just key this in the calculator. We're going to key it in the calculator on degrees to get an answer for degrees. We're going to key it in the calculator on radians to get an answer in radians. So I'm going to set it to degrees, DRG, then hit deg for degrees. And now I'm going to do cosine inverse of 245 divided by 340. And the answer we get is 43.9 degrees, rounded. So y is equal to 43.9 degrees. It's actually 43.8969, but if we round to the second decimal place, the 0.89 becomes 90 or just 0.9. Okay? All right, so 43.9 degrees. Now let's do it as radians. So I'm going to hit DRG, go over to rad, and I'm going to hit cosine 245 over 340, gives me 0.77. So 0.77 radians. All right, so I have this answer now both in degrees and radians. So what I'm going to do is I'm going to come over here and I'm going to erase the y, and I'm going to put in, whoops, let me accidentally erase some of the line. I'm going to put in 43.9 degrees. And now you may think, oh, now we have to go to another example to get the third angle. No, to get the third angle, remember, this is a triangle, so all three angles add up to 180 degrees. So all we have to do now is do 180 minus this will give us this one. Okay, so 180 minus 43.9 minus 35.3 gives us 100.8 degrees. And so this angle up here is 100.8 degrees, which we could then convert into radians using our pi over 180 conversion factor. And now we know everything about this triangle. We have all three side lengths, and we also have all three angle lengths. So isn't this awesome how the law of cosines can help us find everything that we want to know about a triangle given certain pieces of information, okay? All right, what we're going to do now is we're going to do a couple of examples where we are going to find the length of a side given two sides and one angle. All right, so what we're going to do in this example is we've got our triangle, but in this case we have two side lengths and we have the angle measure that's between the two sides. So we can't use the law of sines because we don't have the length of the side across from the angle measure, okay? But we're not even looking for an angle measure anyways. It says find x. It says find the length of the side that's across the way, okay? And so we can use the law of cosines for this. Now, remember that I said that whatever it is that we're trying to solve for is c. So we're trying to solve for a side, therefore this is side c, okay? So we're going to put an x in wherever we see side c, which is right here. It's going to be easy because it looks like the x is almost isolated. So we're going to go, we're going to put an x here. We got to give names to these other two sides here. The angle across from what we're looking for has to be angle C. So this is going to be angle, or let's put a capital C up there. Has to be angle C. And then we have to name 38 and 46. Let's call this one A and we'll call this one B. Okay? All right? So find x. So we're going to put x for c in for c squared. So we're going to go x squared is equal to a squared. A is 38. So we're going to put a 38 here squared plus b squared. B is 46. So we're going to put a 46 squared here minus 2 times a. A is 38 times b. B is 46 times cosine of angle C. And in this case, angle C is the given angle, which is 76 degrees. So cosine of 76 degrees. Okay? Now we have to make sure that our calculator is in degree mode when we solve this eventually. Okay? All right, so now let's bring down our x squared. X squared equals. Now here's something I want you to see. In this particular solution, everything on the right side of this equation is now a numeric value. So we could actually just key all this into our scientific or graphing calculator and get a number. So let's go ahead and do that. Let's do 38 squared plus 46 squared minus 2 times 38 times 46 times cosine of 76. My calculator is in degrees. And then I'm just going to press enter. And here's what I get. I get 2,714.241053. Okay? I don't want to round yet because I'm not at my final answer, but I'm almost done. Look at this. All I have to do now is solve for x squared is equal to this. So I just got to do the square root of both sides. Square root here, that'll cancel the square, and x is equal to the square root of this thing. So I'm just going to do square root of my answer, and that gives me 52.1. 52.1 is the length. So over here, x is equal to this side length is 52.1. Okay? All right, so now let's say that we wanted to find the other two angles here. Well, we then could just use the law of cosines to find the angle here. Using this as B, we would have to change this one to A. We would have to change this one to C because it's across from what we're now trying to solve for, right? So if we're trying to solve for this angle, this one becomes C. Then we can just use the law of cosines with these three sides and solve for this angle. Then once we have this angle, we have this angle, we have this angle, that will then get us this angle, and we will have all three angles and all three sides, everything we need to know. Okay? I'd like to do one more example where we find a side length given an angle and two sides. Okay, so we have another example here. We want to find the length of y, and y is this missing side length. We know that the other two side lengths are 19 and 27, and we know that the angle between them is 63 degrees. Okay. Now, we could also do this in radians. You could be given this in radians, but in this particular case, we're doing it in degrees. And it wouldn't matter. You just have to change your calculator to radian mode if it was given in radians. Okay. All right, so we're going to use the law of cosines. Why? Because we don't have a side and an angle measure that are opposite each other. And in using the law of cosines, whatever we're trying to find, if we're trying to find y, that has to be either an angle C or a side C. So this has to be side C, okay? And the angle opposite of it has to be angle C. Okay, so this is angle C, this is side C. We're trying to solve for that. We'll make this one, we'll make that A, and we'll make this one B. Okay? All right, so let's go ahead and set up our formula here, our law of cosines. We're going to replace the C with letter y. So instead of c squared, we're going to have y squared is equal to a squared plus b squared. So a is 19. So we got 19 squared plus b squared. B is 27. 27 squared minus 2 times a, that's 19, times b, which is 27, times cosine of angle C, which is 63 degrees. Now I want to do this one just a little bit differently. I'm going to show you how you can actually solve these side length problems really in one shot, just by entering the whole thing into your calculator. So last time we entered this into the calculator, we got a number, we brought down the x squared, and then we did the square root of both sides. Well, what we could do here is we actually could just start off by doing the square root of both sides. And so by doing the square root of this whole thing, we can key this entire thing into the calculator. Over here, the square root and the squared cancel, and all we have left is y. So now all we have to do is just key this whole thing into a scientific or graphing calculator, and we get our answer, okay? So I'm going to key in square root, big square root first. That's what I say to my students, big square root, because there's a lot of stuff under it. So I'm going to hit square root. Now, my calculator opens up a parenthesis. You want to be very careful with these parentheses, okay? That means that as I open and close other parentheses, now that is not this parenthesis. I need to warn you. This parenthesis right here is not the one that they opened on the square root. What this calculator is basically doing is it's opening a square root and then putting a parenthesis here and expecting you to put another parenthesis over here. So I have square root of parenthesis. Now I have to start with another parenthesis. Okay, that's assuming I'm going to use parentheses. My calculator actually allows me to go 19 squared without parentheses, but if you're using parentheses, you've got to start with a parenthesis here. Or you can just do 19 squared in another calculator and put that number right here. Okay, but what I'm going to put in here is I'm going to put 19, parenthesis 19, close parenthesis squared, but 19 squared plus 27 squared minus 2 times 19 times 27 times cosine, and I'm in degrees, cosine of 63, and then I'm going to close off the parenthesis on the whole square root, and I press enter, and here's what I get. I get 24.98. 24.98, and that means that the length of this side here is 24.98. 24.98. Okay? All right. Well, I'll give you plenty of practice on this. Law of cosines, it's not that hard. It's big, but it's not that hard. Make sure you do lots of practice, and you should be in good shape.